Hello and welcome back. In this lecture I will discuss law of gravitation using vector notation. You know how to find magnitude and direction of gravitational force between two particles. Suppose we are considering, we have selected M2. So we want to find force acting on M2. Then you know magnitude of that force and direction. Direction is along line joining and attractive. So this is direction of that force, say F, and magnitude is G M1 M2 by R square. We want to convert this into vector equation. So most simple method is multiply by unit vector. Most easy vector to write is, try to recall, I have discussed that. In kinematics, most easy vector to write is position vector. So let us multiply both sides by r cap g m1 m2 by r square into r cap. So this into this, we can multiply by r cap. R cap is dimensionless, unit vector is dimensionless. So this will give you vector f equal to g m1 m2 by r square into r cap. Now this r cap is vector r by its magnitude. Now to write position vector, what you need to know? Coordinate of tail and head. So in this diagram, we know the distance is r. How to involve r vector or position vector? You have selected M2 and who is playing role of environment on selected body? Force is because of environment. So in this diagram, we have selected M2. Let us mark it. And who is playing role of environment? M1. So this is vector r. Where is tail of that vector and where is head? So tail of vector r, the tail is at environment. In this problem, in this diagram, tail is at M1, but let us have a general term. Tail is at environment, and where is head? Head is at selected body. Head is at selected body. Where is tail? At environment. Head at selected body. Now, is vector r and vector f in same direction? Look at this diagram. This is direction of r, this is direction of force. They are in same direction or opposite. So, is any correction required here? Answer is yes. This is r cap, mind you. We have shown vector r. R cap and vector r will be in same direction or not? Unit vector is always along parent vector. So r cap is in same direction as vector r. So this r cap and f vector is parallel or anti-parallel. So we need to append what sign? Minus. So this you can say is law of gravitation using vectors. And instead of r cap, if you substitute vector r by r, what we get? Minus g m1 m2 by r cube into vector r. So Newton's law of gravitation using vector notation becomes f vector equal to minus g m1 m2 by r cube into vector r. Let us verify this. How we can verify? Let us consider or find force on M1 because of M2. Let me draw another diagram. M1, M2. this separation is R. Selected body is M1. Selected body is M1. So who is playing role of environment? M2. So what will be, where will be tail and head of R vector? You will draw vector R like this or not? Where is tail? Tail is at environment. Head is at, so tail at environment, head at selected particle. And you know direction of force here, line joining 2 and attractive. So this is force. Force and vector R. This is vector R. R cap also is in same direction. Vector F and R cap or vector R, they are parallel or anti-parallel. So how much is magnitude? G M1 M2 by R square. And in vector notation, you will get this minus sign as well as R cap. So this F becomes equal to minus G M1 M2 R cube into vector R, isn't it? Because again, how much is this R cap equal to? R by its magnitude. So for both M1 and M2, what result you get? Different or same? Same. So this is what is known as Newton's law of gravitation using vector notation. So what is this R? Tail and head. Where should be tail of this vector R? Just keep this concept in mind. You are not supposed to mention it anywhere, but keep that thing in mind when you are solving problem. Where should be tail? At particle which is playing role of environment. And where is head? At selected particle. At selected particle. Done. And why this minus sign? This minus sign is for what purpose? This minus sign is because force is attractive. If suppose for a moment, let us assume that gravitational force is repulsive force. If gravitational force is repulsive force, then in what direction this F will act? In direction shown or opposite? Opposite, that is, it will be parallel to vector R or R cap or not in both the diagrams. So what sign you will get? Plus. So this minus sign is for what purpose? Force is attractive. Force is attractive. Now, another form, let me put it in form of a question. Suppose this is x and y axis. You have two particles. Draw this diagram, M1 and M2. And position vector for M1, M2 is given in that question. R1 and R2 is position vector for two particles, M1 and M2. How much is force on 2 because of 1? We have to write that force using vector notation. Force on 2 because of 1. So how will you write that? So which particle we have to select? M2, who is playing role of environment? M1. To solve this question, let me draw another diagram. Draw this. M1, M2. This is selected body. Where should be, and these position vectors are given. Now we want to involve vector R. Vector formulation that you know is minus G M1 M2 by R cube into vector R. Where should be tail of this vector R? At environment. Who is playing role of environment in this diagram? M1. So let me first draw that vector R. This is vector R or not? Using triangle law, you can easily find out that vector r. How much is vector r? R1 plus r is equal to R2 or not? So how much is vector r equal to? R2 minus R1, and then we need magnitude in denominator. So how much is magnitude of this vector r? Mod of R2 minus R1. So what is your answer? You can say F is minus G m1 m2 by r cube into r vector, where r vector is this much and mod of r or magnitude of r is mod of r2 minus r1. But let me write it. F vector is equal to minus G m1 m2. Instead of vector r, I will write r2 vector minus r1 vector divided by mod of r2 vector minus r1 vector to the power 3. So this also is known as Newton's law of gravitation using vector. So again, key idea is to convert Newton's law of gravitation in vector notation, you need to involve position vector, and to write position vector, you need to know coordinate of head and tail. Where should be tail of this position vector? At environment, and head should be at selected body. So if you keep that concept in mind, you can solve each and every problem. Now, only issue with law of gravitation is it is applicable to how many particles? 2. Now, what happens if we have multiple particles and you have to find how much is resultant force? Next, let us discuss that.